Okay, so guys, I wanted to start this off with a kind of a trivia quiz, and it really relates to what I have on the screen here and what I have on my shirt. This shirt has a one-time use today, so I need to put it to some use, all right? When I first built this list of digital tools, I was a little bit surprised, and I think that probably that's the reaction of several people in this room that didn't know we had the wide variety of tools that we have. These two are easy. These are brand new lasers. And this is the Nova 35 and the Nova 51 in the next room. And we have classes on those things. Paul is the lead on that area. And so that's two of them. This and this have been the focus of today's presentation, just as we upgraded the lasers and started to teach interesting topics. So too, as we upgrade our CNC, we want to introduce advanced topics. So today is going to be a perusal of 4 advanced topics done by members, and we want to measure people's interest levels. And to the extent that people are interested, we'll try to put some education in place. So this is the Shapeoko XXL, and this is the HDM. And if anybody wants to know the specs, okay? Now, there's a second reason, and I wasn't going to reveal this until I did amongst a few friends here. There's another reason that this is a one-time use shirt. Do you see this? It's not just to let you know my name. I don't usually wear a badge. I didn't reverse the SDFWA logo, so it's backwards. And so I will reveal my error after this, so you guys can actually mock me in public. But this was a way of covering up my mistake. Okay? Let's continue along here. What's this, folks?
Which should be a class I want to film really quick.
Yeah. Oh, what? Shape or origin, correct. And who's the lead on this?
Jeff.
Where's Jeff? There he is. So if you have questions, he's the man to talk to. He's got a class coming up that's already filled for this next month, but he's regularly offering sessions to use that. Now, what haven't we covered on here? We haven't covered this or this. What are those two things?
Or the vinyl cutter.
That's the last thing, yes. So this is the resin 3D printer, and this is the filament 3D printer, and they're both right next door on opposite sides of the room. Those are Chris as a lead, and also Jenna. How do you say your last name, Roswell?
Yeah.
Okay, so those are the two who are teaching classes on 3D printing, and they're the contact people. Now this one, and I didn't even talk to David before. David, okay. So we have this as a resource. And you'll see things all over the place as part of Shop 3.0 where we needed to create a stencil to print. For instance, just above the doorway it talks about how this is the Anderson suite. And that was done using the vinyl cutter. It's a resource for the shop. We haven't figured out how to open it up to the extent, just as with classes on CNC, if people express an interest, we could maybe turn it into a resource. And there are good ways of using it for woodworking, just as there are good ways of using 3D printers and other things for woodworking. So this is our digital tool suite. It's not just lasers and CNCs. There's quite a lot in there. We have people who are leads on these tools, and there are classes taught regularly on almost all of these tools. Yes?
Well, who'd you say the lead is on vinyl cutter, David?
Well, we haven't got, that's the one that's not out in public yet.
Oh,
We have it, whether we turn it outward or not is based on interest and good use cases and things like that. But let us know, let David know if people are interested, and maybe we can put it out there as an additional tool. It is a resource of the shop. It's used all the time in Shop 3.0, and just wanted you folks to know about its availability and that this is the complete suite. So today is really a celebration of yet another stage in the Shop 3.0 progression. We were so excited when this room and the laser room and the new lasers were in place. Just such great evidence of a great stride forward in improving the quality of what we had available here. And when we brought the lasers in, we said we can't stop there with what we've been doing. We've always taught intro classes, intro classes, intro classes. When you hit 240 people who have taken intro, you know it's time to start teaching advanced topics. And we did, and you folks expressed interest in a couple, and they're going to be taught or are being taught. That's what we're trying to set the stage for today with our next stage, which is the new CNC. So the new CNC you heard about from Pat, you saw it in action, And it's really impressive. It's just so much more rigid and more powerful. You're going to be able to get more precision out of it. You'll be able to drive it harder. It's a lot quieter. And as we upgrade the XXL, the 36 by 36 one that we had from before, and we have this, we want to introduce those topics that are advanced topics. So that's what today is about. We have 4 speakers. Those 4 speakers were given 10 minutes each. I expect your curiosity to drive them a little bit longer. So we'll get started here in just a second, but just so you know, as with the lasers, we have a certification process that we're going to be putting people through. Our old CNCs operated slightly differently from our new CNCs. And yet we bought this CNC in part because 90%, 95% of what you did before applies in the new CNC. But there are some differences. So there's going to be a recertification process that Pat will put people through. And for those of you, and you'll remember this feeling if you're in this group, those of you who said, oh, we got new lasers. I took that class 3 years ago and never used them, but I'd sure like to. We have something called a refresher class that we've done for the lasers. For people who took it once upon a time, just needed a refresher of the complete workflow so that they could get back into using it with confidence. So too, Pat will be teaching refreshers for the CNC. So that will come on after the recertifications. And then after that, in the new year, we have a new lead for our CNC instruction, which is Kurt. Kurt over here is our lead for CNC instruction, and he'll be starting the new intro classes in the new year. So that's the way that we take our new hardware and get people onto it. Recertification, refresher, or intro classes. And beyond intro classes, we're testing the waters with these 4 presentations, and we'll see where we go from there. But with that being said, let's summarize what we have as speakers. We have Chris talking about topographical milling, Howard talking about inlay milling, Perry talking about end grain milling, and Rob talking about multi-pore epoxy. And Rob is so into this, he's looking at his phone, he's texting his wife. Any questions before we get started? I'll hand the microphone over to Chris. No? Okay, take it away.
Hi, Chris Cowger. I've been a member of shop, actually a year as of this week. So Travis asked me to talk about topographic maps with the CNC, which is awesome because I've got all of a week of experience looking into this. So the level of detail here is going to be, I think, a little bit less than you're going to see on some of the other topics, but hence art of the possible. Travis asked me to do this, I think, because I've been playing with the laser with maps. I've just kind of got an interest in maps. I'm going to walk through my journey here a little bit with the laser. Okay, so this is just, screenshot off the internet. So laser, right? You can go get these map files, do the vector, and this is just a simple engraving, which is kind of nice. It's a nice product. But what I like about the laser is you can start doing stacks of stuff and get a little more depth. Okay, so this is now 2 layers, and this is actually my first attempt at doing something like this. So this is my product. It's over here somewhere. But you've got a land layer, right, the water. These are easy to do, easy to download the vector files, cut out your layers, finish, and start to get kind of a better, more depth of product here. This would be the next step up, where you've got a base layer, kind of the roads etched, and then cut out for the highways and stuff. Again, you start to get more of a 3D look, more depth. This is another one I did. Okay, so now you're going down with the layers, but this is, I think, 9 layers. And you start to get more of, again, a 3D effect. Again, pretty easy to do, right? You can export this stuff. You can buy patterns on Etsy or whatever. But you can also create these things pretty easily with free online map features like Snazzy Maps.
Okay, little. That's actually I've kind of painted on this every once in a while, but
Yeah.
where do you get the map sources, you know, other than going Etsy and paying $25 for one? Where can I get, like, I like a lake, I want to do like lake up like Laguna. So snazzy maps?
Yeah, I've been using Snazzy Maps. There are a couple other, online features or sites where you can just pick your geography, download the vector file, then you need to bring it into, or you download the image file and bring it into something like Adobe Illustrator,
Okay.
or I'm using Inkscape, which is free also, and do some conversions. And I've got links to some YouTube files in there that are kind of like tutorials.
Most states, like Department of Natural Resources, will have
Yeah.
all the lakes in a database.
Yeah.
And the only issue there is that it'll often be PDF maps, but the quality varies a lot depending on how old the original map was.
And then can you, because the really cool thing that you're doing here is you're actually doing different colors for the different depths. And in CNC, you can basically cut a layer for that depth, which is really, I mean, that's what really adds character to this, right?
Yeah, this you could do with the
So,
CNC as well.
Getting
right?
that information out of the geology maps is really, that's the key, is where I've gotten
Guys, you can really tell how Perry's mind works. He didn't see this as a laser project. He saw this as a CNC project.
And he's gonna pour different color resins.
That's right.
We're already there.
Don't give away my presentation.
Love that idea of the different resins. One of the reasons I started with the laser stuff, though, is I found it easier to finish, right? Because you're cutting out these layers. These are just painted, but then it's glued together, right?
Yeah.
So I don't have to worry about a final milled product with depth that I'm trying to finish different colors. And I'll show some examples of that with CNC projects. But okay, so next step, topographic maps. Kind of grew up as a kid looking at these and just liking the features and sort of imagining the different depths that the maps are trying to illustrate. And you can do these with the laser as well, right? The different layers, and now you're going up. And I like the look of this. It kind of mimics the slices of the topographic map. If you're at all like me, this would be a horrendous pain to try to put together. This top layer, it's like, I don't know, 9 or 10 layers, and those little pieces that are going to fall through them.
Oh, yeah, yeah.
Okay, so, and it's also, again, it's slices. The beauty of the CNC then is you can do something at this level of detail with, different end mills, different passes, and get a real view of the topography. Now, again, I have not done this. I've got links to tutorials on YouTube of where people are doing this. Travis asked a week ago, so I've got like maybe 4 nights of research on this. But it's possible. And the hard part, at least previously the hard part, was getting the files. So once you have the 3D model, if you're comfortable with VCarve, you bring it into VCarve and then set your tool paths. And in theory, you can do this fairly easily. Couple more examples, and obviously these are all just stolen off the internet. But what I wanted to show here is the way people are finishing some of these things. And from my perspective, again, much harder, but some beautiful results if you have the patience and talent to do some of this stuff. Okay. The last 2 slides are basically just links to resources to get some of this data. I'm actually going to go out and look at that site specifically.
So just for those who don't look at the letters STL and recognize what they represent, that's the file we typically use in 3D printing, and that's something you can import into VCarve, and you can use that imported 3D model to actually define the contour of your cut. And so that's basically the magic behind this, is if you can get that STL imported, then you can use it to define tool paths and get these kinds of results.
Yeah, so it's any kind of 3D
Right.
model that you would bring into VCarve and then carve out in the CNC. It's just this there happens to be topography. So the site is really just asking for latitude and longitude, and there's a variety of different details here on the level of detail you want to export the STL at, how big of a swath of land you want to cover, and then, you know, depending on the detail, it'll take a couple minutes to generate the model, you download it, and then you've got your STL file to do whatever you want to do with it. So,
You put those 2 links back up?
And if you guys are okay with it, Chris, I'll ask if you could provide them, and we'll get them out to the group as a distribution email.
yep.
So I've gotten here before on this, but the real meat is when you go to cut it. So I've got the 3D model, actually 11.5 Aspire or VCarve
Just came out,
lets you look at 3D models a lot better than in the old versions. So I highly recommend if you have an upgrade, if you have it or you want to upgrade, I'm sure you guys are about to upgrade here. You can actually edit 3D models and actually see the results rather than kind of guessing back and forth. But when you have that 3D model, what bit progression would you use to cut this?
In all of my wonderful experience. So what I've seen is everybody starts with something large, right, and clears off the first path, and you're basically going to the highest point of whatever the
Sure.
mountain range or whatever you downloaded is. And you just, I've seen people use up to 4 different bits to get fine detail.
Go ahead, Fitch.
I don't have a whole lot to add other than it's just getting finer and finer and finer.
And lots of time.
That's it,
Lots of time.
Patience is the big
Book
ingredient.
10 slots in consecutive.
Sometimes I
Yeah.
work for a larger 3D, just the cut time is beyond our slot time.
Yeah.
Yeah,
But you know what, for the privilege of us seeing your work and you accomplishing something like that, we should be able to work something out, okay? So if you've proven a project and you just need an extra hour or whatever, we should be able to make that work for you, okay? There are certain times when they have back-to-back slots, for instance.
Well, and sometimes you can use reference pegs and come back and.
True. If the bed is in exactly the same condition it was when you last
Right.
left it.
I wouldn't, not anymore. I wouldn't.
They'll say, what's these holes in the spoil?
Right. So, anything else, folks? Because as I hear this, I had this small epiphany that he kept referring to this as a 3D milling exercise. And it really is. We brought in a 3D design that happened to be topography. And it's a really cool use case. But frankly, if it was more generalized as 3D engraving, where topography was the use case for the class, that would be a topic that if people were interested, and I could see us easily teaching a class on that. We touched on it in our old VCarve class, where we did this magnolia, the flower. But that was really just the intro, we never went beyond that. So this is an advanced topic that's being pitched by Chris, and so just for your consideration, maybe 3D engraving is the thing. Perry?
So I'm actually going to go off topic on my presentation just a little bit
Okay.
toward the end.
So-
and on the lines of 3D milling,
There we go.
young Howard here has done.
You like that, don't
Do
you?
you have your badge?
Hmm? Oh, the police badge?
Police badge?
Yeah,
Do you have a picture of it?
I do.
Maybe just
Is it part of your pitch?
if we could
No.
talk in.
Oh, okay.
What could it be?
It could be.
Like an extra 5 minutes? It'll be very. I mean, you've seen it obviously.
Yeah.
It's absolutely incredible. So if you could even if you give the Reader's Digest quickie, I'm sure it would be a big benefit for everybody.
Now for the people under 40, you
Sorry
have to
for
explain what
volunteering.
Reader's Digest is.
Yeah, what?
Go ahead, Chris.
Talk for books.
Questions?
Yeah, do you have to use VCarve for all this? You can't use Motion Create, right?
Want me to answer that? Okay, so Carbide Create does have a premium version, which does include 3D engraving. And I think it's $10 a month. And it's something you simply subscribe to from within the free version. I've used it, it certainly does the job. But really, the pro package here that's free to you, if you're only using the CNCs here, is VCarve because of the Makerspace program.
Yeah, but with the new machine, there's some advantages to Carbide Create in the tool changing process.
There is, but if you're doing something that takes 5 hours to cut, you're not really too concerned about the 2 minutes in tool change. Did you have something?
Yeah, vertical limitation on the new
5.7 inches. 5.7 inches.
Wow, that's good.
You gotta get my eyes checked.
He's not so strict.
Sure, not
Yeah.
Quick question about, you said the STL file that it uses?
Yeah.
And I think I misunderstood the 3D portion of it. Is that the same thing that's used for like the additive process for 3D printers?
Yeah,
Similar
same.
file.
It's the same file. Yeah.
Is it something where you can like do like a hybrid or something to where you can do some of it to remove material on this and then build something to kind of like merge something together with a plastic versus?
So are you talking about a mixed media kind of project? Very interesting. If you are milling to enough detail with the CNC such that it matches the level of resolution and scaling on the 3D printer, yeah, there's no reason you can't fit these pieces together.
It just would be the software that you would use?
Yeah, the software, because it's an STL file in either case, and it's how you set it up to be printed or set it up to be milled. But if you haven't, if you're in your mind's eye, you're trying to bring them together, you can certainly do that.
You can do slicing, right?
Yeah.
You can do slicing, yes.
Yeah, basically, take whatever model you're doing and then basically slice it. And create submodels, and then take the base and do CNC, and then the next one 3D.
Oh, that's a
or
vertical, that's interesting. So
Yeah.
here's things like, take a mountain, plastic wood, plastic wood, plastic wood.
Yeah,
You
right.
could create different slices and do that. I understood you'd be doing pieces together, but
Well,
that's a very interesting
Initially
idea.
it was for the topographical, because I know you're talking about
Oh, I see, yeah.
epoxy or whatnot.
If you want to know.
Hello?
Hello.
Okay.
Hello?
Hello.
Okay, how many people here have already done a VCarve inlay? Okay, so there's a lot of you that haven't. So this can be one of the most dramatic but easy jobs to do once you have a few figures to put into your VCarve program, Aspire, whichever one you're using. I'm going to pass out a cheat sheet that will take you through all those figures. There's a QR code on the bottom. That QR code will take you to the video I did on YouTube, which is about a half-hour video, and it'll show you every step that you need to do this first time out of the chute. And I've only had out of about, maybe, I think I have like 80,000 views on that. But I've only had 3 people call and say, it ain't working. And then I get on the phone with them and, oh yeah, we forgot to do that part, and so on. So I'm going to briefly go through what I do. Yeah, you can start passing those out. When we do these VCarve inlays, and you can start passing that one around, you're going to do a male and a female carve. The female carve is very simple to do. I mean, this thing, you just put on the VCarve bit, you carve your lines from your drawing, and it's absolutely no issue whatsoever. But when you come to the male part, you have to flip your drawing, and I'm going to show you, and that cheat sheet will tell you. And the reason you're flipping your drawing is because when you cut these, they got to fit together. And that's why you have to flip your drawing in VCarve. Also, once you have these carved, they're going to go, you see how that snaps together? That's what you're looking for. And it'll work every time, except for the first time I tried doing this. I'll give you a quick little thing. I did both sides. I go to put them together and nothing's fitting. And I'm thinking, oh crap, I got to do this class and I don't even know how to build these damn things. So I went to bed that night thinking, what the hell did I do wrong on that? And then just going through all the things, I bet I used the wrong, bit. And I did. I had it set up for 30 degree and I used a 60 degree bit. And so when I did it the next day, everything worked just fine. But that's what your goal is, to have that fit. And it don't matter how elaborate this thing is. It can be, 50 stars on the flag. It can be any intricate drawing. You'll be shocked at how this thing will fit together. And, it's just amazing when you do it. but I got a little quick video. It's going to show you why we do the different things. On the mill, when you're doing this one, and you got your drawing, you're using the same vectors that you use for the other ones, but you flipped them. But you also got to put a vector around the whole outside, and I'll show you why, because we got to clear out all this wood when we're cutting this. And being this was a small enough piece, I cut it all out. But if you were on a big sheet of wood, you're cutting it out, you could just draw a vector around and then cut it off on the bandsaw to save some wood. But let me go ahead and show this, and then it's only 8 minutes. It's the shortest video I've ever had here.
What CNC is this?
This is the Avid Desktop Pro 24 by 36
With a rotary,
with a rotary that I made
laser head.
and a laser head. This is the slow part. It's about a minute. And so what I'm doing here is I'm clearing off the wood. We're clearing off all this wood from around where the mill part is going to be.
I think for your videos, you gotta take the shroud off.
I know. I did on the female side.
Is this sped up?
Yeah,
Oh, and we were talking about not doing the tape method down there on the thing. I've modified the tape method that works better because your MDF is sort of porous. So I just take a sheet of MDF and I glue my piece down with the tape onto that, and then I hold that board down so I can be further out with the clamps. So it just works out good.
That's a good idea.
VCarve on that section.
That's a slick idea.
What bit were you doing the current with camera?
I used a 60 degree.
The second time.
Yeah.
What did you ask?
No,
Yeah.
you did 30
So
first,
you're
right?
still using the V-bit for the clearance? Come on.
Turn it on. And I did leave the shroud off for this because it ain't quite as messy. But you wouldn't think as way it's chopping this away that that's going to come out and be very fine detail. But it is.
Is that poplar?
Yeah, that one's popular.
Ooh, that's tough. That's a tough one to do. Fuzzy.
And I don't like it that much. I'd rather use maple because maple's harder. This has kind of stringy threads, but it still cleans up real well.
Especially for the fine parts. Really thin lines.
And that's real time. Right there.
How much post-processing do you need to...
How much what?
How much post-processing do you need to get the fuzzies out?
Oh, not that much. I mean, this whole inlay that I just did, that took about maybe 15 minutes.
Something that I've tried that worked is I've actually run it on a completed design again. And that actually gets rid of a lot of the fuzzies. Even though it's already been cut, you just run it again. It actually does a good job getting rid of a lot of the fuzzies.
So you run both parts with the same V-bit?
You use the same vectors for both parts. It's just that you put that frame, another vector around the outside of that mill piece, and that way it'll do the reverse.
So, quick question. One of my issues, and I think you just told me the answer in the video, is I was using like an 1/8 of an inch end mill to do the clearance. And with a start depth of 0.2, that's a big depth of cut for an 1/8 inch.
Yeah.
In reversing colors. And so what you're trying to obtain, you've got the male and you've got the female. And when you put these two together, you're you're looking for this thing to like snap into place, just like that. You can feel it just drop in.
What gap do you go for
So that makes it very nice.
between the
When we
two?
glue it up, it's
I
like
have no
perfect.
clue, I just know it works.
And by saying it worked, it's the cheat sheet dimensions.
Yeah.
It's all in here, it's all in here.
So that's what we're trying.
And what I failed to mention is, well, let that go.
I'm gonna save one just as a sample, but I'm gonna glue this one up, and then we will have the blackbird and the white wood. Or no, actually, yeah, that's the way we go.
You can see how you
Okay.
move those little all together.
Okay. So I'm gonna go ahead and glue this one up, and I will make sure that I have glue everywhere.
And if you were on a real big job, you could just like glue up one section and then clear it off on the CNC machine. And when you got a small inlay, you can just take it over to the bandsaw.
What he's doing, both parts, don't try to cheat and just do one. It's really important to do glue on both sides, because I have,
You've tried to cheat?
I tried to cheat, and guess what?
Didn't work.
Well,
Yes,
this,
sir.
I find if I miss a little piece on one, if I do both pieces, the chances of missing the exact same spot
Right.
are pretty slim. And I'm watching the video and I'm wondering, well, how come you didn't get glue in this piece? That's the ink mark for the center line. I'm looking at it myself.
Right.
There we go. And then I want some pressure. This, by all means, are my favorite Bessie clamps. These put so much good downward pressure, and they've got a long throat, so I can get right in the middle, and I'm gonna get good clamping on that.
How come you haven't built a press yet, Howard?
Dry,
How come you haven't built a press,
and then
hydraulic press
we'll
yet?
cut it off.
No room.
No room.
And he's got a lot of room.
And then we'll sand it. Okay, so what we're gonna do is cut right through that line. I've already got this.
And you're just a little bit proud of the finished piece, so you ain't gonna scratch it or nothing.
And let's go ahead and get this done.
Yeah, I got a little hung up there. And there it is, finished.
Great,
That's
man.
beautiful.
All that hard work, look at that.
Put it in the fair. Abstract.
Okay, so now, that's where we cut that off, so we're gonna sand that.
I'm questioning whether we should have asked him to do it. But if that's the result. There's the great reveal. Oh,
That's beautiful.
I figured we always see the handout. I figured, kind of nice to see how we got there.
There you go, we got a perfect VCarve inlay, all tight corners. Now it's just a matter of finishing it.
that is the magic. Like the tightness between the grains on such intricate patterns because of the computer-driven milling and then the compression. It's just incredible results.
So, any questions so far? Because that's pretty much it. Yeah, go ahead.
And it doesn't have to be just like that block. You can do it on any work that you have.
Oh, yeah. Yeah,
I think he's intrigued.
the only thing you got to remember, like let's say you wanted to put this on a wooden table you had, like a kitchen table, and you wanted to put an inlay in there. You can put the inlay in there, but how are you going to get that waste off the top if it's a big table? Because you can't carry the whole table into a bandsaw, nor can you put it into a CNC machine if it's that big. So you got to know what your limitations are. Probably that's where a shaper origin might come in handy for something like that.
Or the sled.
With a sled.
Yep.
Yeah. But if you're on your $8,000 table and my wife ain't gonna be saying, hey, you just put a sled on there. Yeah.
The other way that I've done it in the past is I do all of the inlay work on a separate plug, and then I take that plug and I just do a pocket cut in the middle of the bigger piece and then drop it.
Right. As long as you got, if you're doing a bigger piece that'll fit in your CNC, it just makes it, you know, you can cut all those off. You could do multicolors. You could have, like, let's say you were doing a bird and you wanted the wings to be maple and then you wanted some veins in there to be brown. You know, you can use mahogany, and maybe the eyes, you want something there, you get something. Do we have a blue wood? I don't know. But, you know, you can do different things and, you know, make almost like a, what is it, macrame, or what do you call it?
Marquetry.
Marquetry, yeah. So you could do a semi-marquetry. But you can get quite detailed with this. There's my signature that I took. I ran it in through VCarve and got it vectorized, carved it, doing the exact same process I did here. And that's to define a detail that'll still slip right together and, you know.
If you've done this before, you realize how significant that really is. Because, I mean, the water lines and the nice, you know,
What angle do you do?
1/8 inch.
That one was, I think, a 60-degree.
Oh, really?
Yeah.
Yeah.
And now I've got a 15-degree that, because I've been watching that Brothers in Wood, or like me, I was always trying to call Broen and stuff like. That's what I thought it was. And that's the abbreviation for Brothers in Wood. But like this was just one I was playing with one day. I got some fancy stuff and just threw it in. I was using, I'm not sure what the light color wood was, but you know, it was one that got real thready and didn't work as well. But that's still, you know, pretty close and tight.
So you have a start depth of 0.2.
Oh yeah, I forgot to go there.
I have made the mistake probably of using an 1/8 inch end mill to do my clearance pass on the mail.
Yeah.
That's a big depth of cut.
That's way too small. If you're doing your clearance depth, you want to use.
Well, I mean, if I'm trying to get it like the bird you have on your handout.
Yeah.
I mean, I can't get anywhere in between these feathers.
Your VCarve bit will do that.
So you're saying basically use the VCarve bit for the clearance within the body.
Well, no, you have to use it. Yeah, and it'll do it very precisely. And
0.2. So basically, it's going to be 0.2 plus whatever off the 0.1. So it'd actually be 0.225 or 2.
Well, we call this the 3-2-1 method.
Right.
And you'll see there when you do the female part, whatever thickness that is. Let's say that was 30 hundredths, 3.30.
Right.
Then your start depth for the male would be 0.20, and the bottom part there would be 0.10. It works no matter what you're doing. If you're doing 0.2, then it's going to be 2/3 of 0.2 and 1/3 of 0.2. Those figures will work out no matter what you do. You just do a 3, 2, and 1, like 3/3, 2/3, 1/3, and those measurements will come out every time. You'll have a nice gap for your bandsaw blade, and you know, I've seen people like go through the whole math thing and they say, oh no, that won't work, and do this and that, and like I say, out of, you know, thousands and thousands of views, I've had people say it worked the first time, and it will if you follow the directions and, you know, you do everything like you put the right bit in that you're using, and you want to use the same exact bit, because even though it says it's 60-degree, maybe it's 59.
Yeah.
So you use that same VCarve bit for both the male and the female, and follow those directions and it'll work. Make sure you use the QR code to get the full video, and then like and subscribe.
So back to what my question is I'm using a 15-degree bit. 0.2 is a lot of a pretty big depth of cut to start with. So if I really want to get in a lot of fine detail, where I thought the problem is really, really, really thin lines.
I don't think
having tear out.
They don't get any thinner in that signature.
Yeah, I know.
You know, so I mean, it just works, and you know, then you can just start playing with it, you know, and you know, go bigger pieces, smaller pieces. And the one mistake I made, I did do this one, and I wasn't thinking about it. I'm going over to the bandsaw, and it was like a round dish, and I only have like a 16-inch that I can cut, and I started in, and then it's like clunk. Oh no! And then I had to glue it all back down, figure out my zero, and so.
Guys, any other questions?
Okay.
I hope you guys, when you saw this piece go by, and please be sure to take a look at the work, because the way people react to seeing the results of this technique really impacts them. I mean, this is a really beautiful form of woodworking that is made really approachable using a CNC and this technique. So if this is the kind of thing that you'd be interested in, let us know. We may even have the benefit of Howard being willing to teach that class, okay? So this is the second topic. I aired this with him in advance. As long as you subscribe to his channel and like the videos, we'll teach the class. But this is topic number 2. And I personally, I've done a few of these in the past. Every one of them, that the tightness of the line between the woods is just so impressive. And you can't not impress people when you show it to them. Not that that's the goal, but fine woodworking impresses. And this is an example of something that's very accessible with our CNC.
And I will be checking, I got all the emails, I'm going to see how many subscribers I got. By the way, we are up to about 3,000 now, so.
Wow, I remember we just passed 1,000, that's great.
So we're getting there.
So wizard is the best way to describe joist cam. Basically, you pick which one you want. It's overwhelming when you first look at it, but once you get into it, it's not that bad. It tells you what kind of joints you're going to do. You put in the parameters of the spacing of the doves, how high they are, and then you can see what it looks like assembled. Then you put it on my way too complicated fixture. So you can see this is sitting on the fixture with the locks. This is the complementary piece, so you're cutting both sides of the joint at once, so you know they're going to match up. And what you do is you basically offset the piece that's on horizontally on the table, so that it has the correct basically spacing to merge through the other.
How did you get the head of the machine out?
I'm sorry?
How'd you get the head of the machine?
It actually goes forward. I think I had 2 inches to work with. So I had to be really careful about, that was one of my mistakes as well. In making this too complicated is I had to have a support base, which was, I think it was 3/4 inch. So I lost 3/4 inch right away. So basically it's 3/4 inch of this, so I had to be really, really careful how far out I could go. So I could only do probably 3/4 inch thick wood on this. So you'll see, I did one at home, it has a lot more, but yeah, that's the limiting factor for how wide you can make your wood.
That was because the Shapokas came out.
They do, huh?
Yeah.
I don't know if you Travis went out, but there's pipe here?
Does it matter what distance that board is offset?
Yeah. So because basically, when this merges, that has to shift by whatever the distance. So first thing it does is actually does a clearance, so it doesn't make the dovetail bit work too hard. So it actually clears it out first to whatever depth your doves are going to be. There is a dove. And as you can see, anybody who's near this thing is going to get really messy. So dust collection is an issue. Man, it's beautiful. MDF just cuts amazing. so cool. That is. It's funny, I've been watching CNCs go for 3 years, not more than that now. I still never get tired of watching it, it's just incredible. All right. So that's kind of the general gist of what we're talking about here today. Let me see if there's anything. These are all kind of, this is the same thing, doing different types of the same joinery. I don't want to go into it too detailed. Let's do, we'll get there in a minute.
So how did you set up your Avid to do that?
Wow, thank you. This is how I set up my Avid. So I bought an Avid CNC based on this guy's recommendation. And when it first comes in, you see this is set back. So when it first comes out of the gate, basically this joint is right here on the front. So that didn't give me a lot of going off the front. So what I did, there's actually like a $300 and something, I can't remember how it is. Basically, you looked at it, right? This really fancy ramp, it basically takes away like 1.5 feet of your table back here. But I figured, I don't need to get that complicated. So all I needed was I think it was probably like a 2-inch, 3-inch offset.
I think it was less than 2 inch,
yeah. And since this is all T-tracks, I could hold my material. I put another bar going across here. And with a clamp and a T-track, now I can slam a bazillion of these things. Basically, I have 2 T-tracks, you can't really see them going this way, clamped into this. And I basically put whatever width of wood captured between the 2 vertical clamps. And then I'll use 2 rocklers on each side and then one of these if I need to. And if I have the same width wood, like if I'm doing 4 posts per table, I'll take this out, slam the next one in, cut it, and then basically I can go really fast and do a lot of them. So it's the most boring joint possible. This is the, so actually we're looking for a volunteer to adapt this to the new table, right?
Actually,
I
no.
think it's too
Yeah, it won't work. But this is what happens when enthusiasm goes wild. Okay, this guy got introduced to CNC and ran off and built this thing for old Shapeoko, which had enough of an overhang, as he said, the 2 inches, to be able to hold the wood vertically.
It was like 2 months of design. And
Yeah.
I don't mind it for a second because you'd be amazed how much I learned doing this, including learning fusion. But yeah, this is when you have way too much time on your hands.
Newly retired at the time.
You want to make something as complicated as you possibly can. It worked very well, by the way.
It did.
But then Jerry's not even here. Jerry walked by one day and he just really like rained on my parade big time. He goes, "Why don't you just clamp it in front of the CNC?" Get out of here, Jerry. That's way too easy, man. I've done all this work and you're basically just throwing it in the dumpster. But you know what? One thing I like to admit about myself is I can tell when I'm wrong.
Travis, is the HDM going to be set up so we could hang stuff in the
Good
front?
segue. So let's go back to this for just a second.
Okay.
This was amazing that we had this. And it ended up being something that wasn't used that often. And this notion of the vertical milling on the Shapeoko sort of fell a little bit into the background. As a consequence of having the new machines, which currently can't do vertical milling, okay, they cannot right now. But if there's enough interest, there's no reason why we shouldn't go down that path. It's obviously possible. He's done it on multiple machines at this point. And in addition, if that's modest interest, we have the Shaper Origin, which can do some of these things. It's this tool here. It's like a CNC that's hand controlled. But to answer your question, the HDM and the upgraded Shapeoko XXL cannot do the end grain milling. It's a really important topic because of the joinery possibilities in it and the exotic aspects of it, which you can see evidenced in what was going around, and I'll show a video of what he did years ago at the end. It's worth considering putting into our training, into what's available to folks. So we want this to live on. Shayla purchased the smaller CNC that we had, and this is going along with it so it can get some good use and joinery on that CNC. And this is what an exciting dance looks like.
So first of all, can everybody in the back hear me? I used to teach, so you can hear me okay? Yeah. Okay, I used to teach, so I have a very loud voice if I try. So this is kind of taking one step back, but everything, it may look fancy or whatever, but you can do exactly what I'm doing here on your machine. There's nothing special about this at all. So you can see what I was talking about before. These are the holders, hold it basically, so I know I'm basically completely vertical and square with the table. If I need these, I do. Now I have actually 4 of these. I have 4 clamps from here and here. If I can actually do up to 3 foot, I think I figured I can do 3 foot if I go all the way down to this bottom beam. So if I have a post or something that's 3 foot tall, I can actually do the end joinery on that. And mass production, I've done a ton of these things.
And so the really real prerequisite, correct me if I'm wrong, Perry, but the only real prerequisite is that the spindle be able to go off the front of the bed.
That's it.
And at that point then, we've built our tables. Our CNC is shiftable on the table. If that became a priority for us, we could probably make this happen. It's just that it's not there right now. So express an interest to people who do CNC, and we'll make it happen if there's enough interest.
Some of the people on the Onefinity farm have built trapdoors in the center of their CNC machines.
If you don't have the
Yeah,
overhead.
it takes up so much space.
Exactly.
The only reason to do that would be if you want to do a 45 degree or 30 degree end grain cut. And if you can see, I have a poor man's version of that. Oh, wait.
Is a poor man's version of a 30-degree angle,
Oh, yes.
27 degrees?
So you can see down here, this triangle is my poor man's version of that.
Oh.
45 is the most common one I'd want to do. So I basically would just clamp this in some way to do that. Now, what it can do with just the tenons, I used to basically not want to use any metal of all. So this is my miter saw stand. It uses zero metal. Absolutely everything of this, and you can actually see in the side here a little bit, everything is all mortise and tenons. And you know what? I put it together. I did a dry fit. It stood just perfectly, just like that. So you know that joint is just incredible. You're woodworker, so you kind of already knew that. So
That vice mount that you and I built, Perry,
yeah.
still being used.
Yeah, it's crazy, huh? That was fun. Okay, so now, any questions on this? I'm always, he knows my email, and I love to answer questions, so.
For the dovetails, how much do you have to fiddle with it to get a tight fit? Because I know yours were real loose that you passed around.
Yeah. I made them that way on purpose. If I was going to make it for production and something was going to be sitting in my living room, I would make it tighter. I would make it, I've played with the numbers, 5 thousandths on side is really, really tight. You might have to use a hammer to put together. I've gone to using 8 thousandths for something that I don't care how tight it is. So if I'm going to glue it and I'm never going to see the joint, I'll go for a looser joint, like 8 thousandths per side. So it kind of depends. It also depends if I'm doing multiple things that have to fit together. So if I have a tolerance buildup, I may go a little bit bigger on the tolerances. You know what I'm saying. So it kind of depends, but yeah.
But you have that control.
Yeah.
And that's the amazing thing about a rigid frame, tight CNC, and just being able to dial it into that level of precision.
Right.
If you wanted to have a mallet fit, you can get that. You want to be able to hand pull it apart, you can make that. If you want it loose so that people can easily put it together and take it apart like a puzzle or something like that, you can control all that. And that's the beauty of using a CNC for this sort of thing. Whereas I took the hand joinery class. Oh my goodness. Let's call all mine floating joints, okay?
They are beautiful though, right?
There's a reason we're in digital.
That's right, that's right. Exactly.
And the other piece of that is actually, Fusion 360. I'm not going to show that today, but it's a pain in the butt to learn, but once you kind of get the hang of it. So here is the design you see in Aspire, or it's the same thing as VCarve basically. So you can see this design, and what it starts off with is really complicated. Basically, it's just a domino, and then the female is the same domino, it's just a little bit bigger, and you drill them. The male, as Howard was saying, is just the same thing with a little bit of clearance, and then the square on the outside. So you can see what it's going to do here. I think this probably was my favorite of the ones you see on there.
Which, this is not the computer with 11.5 on, huh?
That's correct. Yeah, this has 11.5.
It's a new another one came out 2 days ago, 11.502.
Yeah.
They've had two since the 11.5 came out.
So the other one that I did this on And this is basically just drawing a bunch of circles. So it's not complicated to do these things. If you can draw a bunch of circles and aspire a V-carve, you can do these. Or even more, this is actually my other favorite one. I have to say that since Travis is here, doing this one. The key to this, it's a little more complicated because you have to think, I have an 1/8 inch bit, because I have to go down 3/4 of an inch to get through the mating piece. So I have to have a bit that's going to go 3/4 depth, and 1/8 of an inch probably is the thinnest bit that I can do that. So you go and you design these letters with the radii less than a 1/16 of an inch. So like all this guy and all this. So you have to go and rework that a little bit. But,
So was that a font, or did you create that?
Yes.
Got it. Modified font.
It was a
Got it.
font, and then I had to go and tweak it.
Yeah.
Yeah. But I'm a CAD nerd. That's very relaxing. I love doing that stuff. So. Let's see.
Do you ever have to worry about the shank hitting the wood as you go down that deep?
Well, they make it. That's a very good. That's a very good point. Yes, you do. They make 1/8 of an inch bits. I think I had like 1.5 inches. You don't want to run too fast or too deep. But if you feather it, if you baby them, basically do really shallow depth of cuts. Don't use a really high feed rate. It's funny because I use the same feed rates almost on my big, huge monster machine as I did back in class. And you know what? It takes longer, but I never break bits. So being conservative, if you have time, is never going to be bad. Never going to be bad.
But they can break real easy.
I was in a hurry and I
The
broke
bits,
2.
yes,
Yeah.
absolutely.
I was doing letters for my boss's son's birthday, and I broke 2 because I tried to speed up the feed rate.
Yep.
And $40 a bit, that ain't cheap.
That's right.
Look at this thing. Look at this phenomenal cuts.
Huh? I'm sorry, I have to do it the second time.
Look at this thing. Look at this.
And as you can see, it's not that difficult. It looks cool, but it's basically a little bit of time in CAD.
SDFWA.org.
What he's going to show you cannot be done without the CNC component. So that's the part to focus on.
Yes, so that's what I'm going to get into first. So the purpose of this presentation was advertised as multi-pour epoxy milling, but before I get to the multi-pour milling of epoxy, I got to cover some other things that are pretty basic that are all about, as Travis mentioned, the CNC. Really, the end result of your multi-color pour epoxy journey, other than the epoxy part, you've got to get this part down first or the epoxy doesn't matter. And that's the same thing that Howard was talking about with his inlays. It's about understanding the concept of what V-carving is and the fundamentals around how you set up your project if you're using V-carving as the main tool path of choice. So there's a couple things I think that's important that we needed to talk about, and then I'll go through some examples of what I mean by this. So the first one is a V-bit is normally used. I have seen a very sharp ball nose, tapered ball nose, 4mm ball nose, and others used. So the typical angles are 15, 30, 60, or 90. There is 120, and there are other angles. Most people think of a V-carving toolpath as simply a sign. It's much more than just for using a sign. The toolpath, the way it functions, if you're not already familiar with it, is it basically looks at closed vectors. And so it goes and carves a closed vector until it reaches another closed vector, until it reaches another closed vector. So if you understand that concept, then what you realize by the way it works is simply by adding another closed vector, you can change the whole dynamic of what your carve is going to look like, and I'm going to show you that here in a second. So the V-carve toolpath starts with the outer vectors, like I said, and it works its way in until it gets to the last vector. The V-bit will go as deep as it can to reach the vector. So there's a vector, let's say the vector is 0.01 inches wide or 0.02 inches wide. Remember, a V-bit is shaped like this, and so and I explain all this on my YouTube channel too, if you want to go like, subscribe. Blah, blah,
Where's the
blah.
QR code?
Yeah,
Where's the QR
I don't
code?
have, I'm not as organized. I don't have 3,000 yet, so I don't have his organization. But the point is, it'll go down as deep as it needs to fill that vector. What's the message there? Well, the message there is that if your bit width at the top, the diameter, is less than the width of the vector, guess where how deep that bit's going to go?
Infinity and beyond.
All the way down into your table and beyond, right? It's going to keep driving until it breaks. So you got to understand how it works and how you control it. So then you use something called a flat depth if you're in the VCarve software. I predominantly use VCarve software. Started out in VCarve Pro, and Travis harassed me into getting Aspire because it wasn't out of his pocketbook, it was mine. And so I do use Aspire a lot, but I do YouTube videos, instructional YouTube videos for Laguna at times, and they force me into going backwards to VCarve Pro again. So I have both, and I can use either one. Frankly, VCarve is all you really need unless you're going to start getting into 3D modeling. If you're going to start getting into 3D modeling, which I do, and making your own models, then you need the Aspire. It makes things work. But if all you're going to do is V-carving, and I'll show you, you can do a lot with V-carving, then you don't need to go to that next step. Or if all you're going to do is use somebody else's model. You know, you're going to buy a model, an STL or a V-carve model, and bring it in. They call it design and make. You don't need it. If all you're going to do is carve, I want to point that out. If all you're going to do is carve the model, you got all that control in VCarve. You don't need Aspire. But if you're going to make the models, manipulate the models, you need Aspire. So understanding how deep a certain bit will go in your design is critical. And on my YouTube channel, I actually have something that I offer out that's called a Schuster table, because I talk about how deep we go with the multi-pour epoxies that I'm going to show you, and knowing how deep that is, because if it won't go deep enough, you can imagine the layer of epoxy you're going to get isn't very much, which means what's going to happen when you try to finish it and you mill it off and you start sanding it. That epoxy disappears. And I'll show you an example of that here in a second. So knowing that is important. And I've actually got a table that explains that based on your vector width, which you can measure inside of VCarve or other softwares, if you know the width of that and you know the degree bits you have, it will tell you the deepest part that bit will go. All right? So if you think you're going to get a 0.02 inch pour and you're using a bit that based on the width of the vector will only give you 0.003, you're going to have a rude awakening. You see what I mean? So understanding those fundamentals. So with that, let's talk a little bit about what you can do with V-carving first, and then we'll go into the multi-pour epoxy stuff. So in the V-carving examples, I started getting into this. This is two videos I did for Laguna where I showed the difference because they would sell the machines and then people wouldn't know how to use them. So that's why
What's the name of your channel again?
Rob Sandstrom Designs. And I'll show you it here in a second. So this was an example of where using the same vectors, this is what I wanted to point out, I got two different results. So the first time, I carved it in, your typical sign, which everybody usually starts with. Let's make a sign. I'll say I carved it, and of course then I painted it, I masked it and painted it and all that. And then the next video I went into now, using the same exact vectors, all I did was add a small vector around the outside here. Remember what I told you, it works from outside to in? By simply adding a small vector, an offset in VCarve, it turned it from a carving in to a 3D version of that same sign. One small change. And it all gets down to understanding how the VCarve toolpath calculates itself and works. I'll give you another example here. So here's a couple other signs that I wanted to show you. Now this has to do with the Shapoko limitations, but I don't know what the rules are going to be here. I've found that we have some rules that may prevent some of this stuff. But the capabilities, as Travis says, so I had a Laguna IQ 2x3 bed. So you would think, well, you're limited on what you can do. The only limitation I have is my imagination and how wide it is. So, and I'm going to show you a couple of examples. So what I'm trying to point out here is you see my sign stuck way off the end of the bed. I'm not limited, as long as I'm using VCarve, which has a tiling process, on how long I can go. My only limitation is what can fit between the gantry, right? So here's 2 different signs I've made for people, for clients, and this one has magnetic characters that switch out, so I just pull that off for the season, so it's a magnet underneath there. And on the characters, I just put a washer, and it sticks on there, and they can change it as they want.
So which season is it that you use the go away for?
That's my neighbor who made sure she wanted me to have one that said go away. So, all right, so here's another example. So that one over there, this is Mike McElhaney, as somebody had mentioned him before. He always wrangles me into volunteer work. So for the fire department or the police department, especially in the early days. So when he found that I knew how to use the CNC, I became his best friend. I think he's got a lot of best friends depending on what their talents are. This is another example. And this sign, for example, is this one here, which that's the back of my F350. So you can tell that's a 10-foot sign that I did on my bed, on my 2x3 CNC. And not only did I do the square, but I did the arch and the arching letters and all that kind of stuff.
That's impressive.
So that's the possibility. You're not limited on the length, is what I'm trying to point out, just because we have a Shapoko that has a defined length.
In this case, it's more we don't have the paths through space in the back.
Oh, if you don't have that, well, that's another issue. So, so now these other things are examples of actual VCarve projects. That's Mike showing off with the police lieutenant and all that. Here's a sign, one of the signs I made, and this is that sign that I carved out across the top. Another couple long signs, started with olive wood. Now the other thing is so this is an example of 2 different types of carves, right? So we've got this carve right here, VCarve toolpath, typical sign method. This carve up here, and this carve up here. Well, this one's carved, no, these both, those are more like a 3D standout type of carve. Simply by changing the way you structure the vectors. And just more examples. I just wanted to show, using the same vectors on these 2, just slightly different, the whole center part is the same logos and stuff, how you can change it. So you should not feel like you're limited to having to get into 3D, jump into 3D immediately. All right. Also, if you understand the capabilities of how the vectors work, when we jump into the next part, which is the multicolor epoxy, you'll have a better go at making those work. So notice that one over there, kind of 3D, standing out. I carved out the background around it. This one here, remember that one in a second. This long. Okay. So now let's get into multicolor pour epoxy.
Can I just make a point? Guys, there's actually an awful lot he's been talking about, which is V-carving. Up in our educational process, we really just get to introducing V-carving for sign making, which is the most simple scenario he was describing. And that might well be an additional topic we'd like to know more about and maybe get some classes around. So you've seen some really important things that he said, especially that it's a precursor to being able to do multi-pour epoxy. So if advanced V-carving techniques is something that would be of interest to folks, that's something we should also consider as possible education for advanced topics.
Yeah, because there is a lot to using those fundamentals, and once you get used to them, what kind of clearance bits you use, stuff that other people have asked about. So, by the way, I don't know if I have enough. I probably don't, because I only made 20. I didn't expect the turnout that we had here. And I think I already gave one away if somebody wants one. These are my new business cards. So,
QR code?
Huh?
Is there a few cards?
No, I didn't think of that, but there's not room on it. I'm going to have to, Howard's going to make me step my game up.
That's right.
But it does have my YouTube channel name on it.
There you go.
And my Instagram, which I do a lot on. So here's an example of multicolor pour epoxy. And you can see on this one here, I've used 2 colors. I've used black, and you see the swirl in there and the white. And if you go back and you look at the same one, same carve right there, you can see it's a little more impressive than just the carve in.
Just so people understand what they're looking at. That is two different epoxy pours side by side with really tight definition. This is really crisp. This really stands out. And if you just look at it as maybe it was painted or something like that, it's a totally different effect. As you see examples from as he goes forward, you'll be able to appreciate that that is a real precise milling process to get that effect with multiple colors of epoxy.
Yeah, so the process basically is first I poured a clear coat, and you can see a line around that here. Why would I pour a clear coat of epoxy?
Bleed.
Yeah, so what happens with paint, you saw that on the other one, right? It had bled into some of the fibers. Anytime you create end grain, you got porous, you put paint or epoxy, it tends to want to bleed out. So what I typically do, when I'm teaching it on my YouTube channel, I have a couple playlists in there, I'll show you where they are, is we pour the whole thing in clear. Now, if you want to go to the cheap, you're not going to go to epoxy, so I'll just give you that. It's an expensive hobby. Impressive results, but it's expensive. Now, other people, and what I used to teach was simply painting it with a brush, a clear coat, and letting it dry. And that will work most of the time. But then you can get into a couple of problems, and it's a lot less stress if you just pour the outside vector with a clear coat, and then you start cutting all of the rest of your design into that clear coat. Yes.
How about shellac?
Shellac doesn't typically work. It will work occasionally. You might get what they say. You want to get lucky.
Yeah.
Okay, go ahead and use it.
Yeah.
So I'm not going to.
Epoxy doesn't stick to it.
So I'm not going. No. It just doesn't seal up the end pores well enough to where you don't get the bleed all the time. Sometimes you'll get bleed. So you can. By the way, what I'm telling you is that's Rob Sandstrom and a guy named Shane Peters' opinions.
Yeah.
You can do whatever you want. You can paint shellac. You can paint lacquer. All of those things. In my experience, I've done shellac a couple times. Well, I haven't done shellac. I did shellac one time. I did sanding sealer another time. Most of the time they work, but not the consistency.
So when you're using epoxy, do you wait till just before it cures?
No, it cures.
Do you let it cure 100%?
Well, 100% is relative, right? 100% typically means, it's going to be a week or 2 weeks or something like that for 100%. For the type of epoxy I'm using for these pours, it's tabletop epoxy, and it typically takes a day. Now, in the case of the epoxy I'm using now is something called moss epoxies. It's LV, low viscosity, and I can typically cut into this into 6 or 7 hours after I make the pour. It used to take me at least 12 to 18 hours with my Upstart epoxy. And now that I'm using this epoxy, under the right conditions, I can typically cut in anywhere between 6 and 8 hours for my next layer. So as he's alluding to, what you see here, this is 3 pours. There's a clear pour, and then in this case I poured the black all within the clear, and then I turn and cut in the white, all right? And then if I had to, I can make any repairs here. This is an example of what, like 4 or 5 or 6 colors, I can't remember, I think 4 or 5 colors. This is one of my first epoxy journeys, and so the first color I think I poured was, I can't remember, it doesn't really matter.
It's the result that counts.
So anyway, and then one of the things I've learned is when do you want to put swirl in and when you don't. So I'll use that as an example. So you can get what you call swirl happy, or I'll call it swirl happy, and that's what happened on one of my latest projects. Well, I really like the swirl. I wonder how that's going to look. And what you see here, I'll pass this one around, is a serving board with 1, 2, 3, 1, 2, 3, 1, 2, 3. I think it's 4. I think it's 4 colors, 3 or 4 colors, and with a clear in behind it. And on this one, I'll pass it around. I'm into a Martha Vineyard kick lately, only because my neighbor has a house there that he leases out most of the time, and he said, come on, Rob, you got to make some Martha Vineyard stuff, and then when I go back on vacation, I can sell it for big bucks because they all got deep pockets. I said, okay, I'll try it. So I'm sorry, so you'll see a few Martha Vineyard things. And in this case, the one downside that I have, I like how it turned out. He liked it too. But I got swirl crazy. Meaning that I think this would have stood out better if the internal island on the Martha Vineyard, I wouldn't have put all the swirl.
Could you remind everybody how you get the swirl there with the mica, just so people understand what you're talking about?
Yeah. So the way, and this was one of the things they originally wanted me to cover today, when I was going to cover epoxy, is basically when you're pouring your epoxy, when you want to get swirl, and I cover this a little bit on my YouTube channel, but I'm going to need to cover this some more because I still keep getting follow-up questions on it. Because when you go look at my playlist, people get a little overwhelmed with how much there is as you go through the process. And what I do is I have two playlists on there where I take a project and I go from start to finish. Not on how to set up my vectors so much, but from start to finish. Setting up your vectors is important. So the swirling process is you first pour it. Now when you pour it, you got to have a couple colors to differentiate the swirl, right? If it's just one. So I typically use, it's mostly a mica powder, which has the glittery part that we talked about, the metallic in it. And then I'll put a couple drops, depending on how much I'm using, of a liquid. I've been using Epoxy liquid, and just switched over to Mixol, only because my buddy Shane, who's the master, is recommending that, so I'm going to try that. And it had more color variations is the other reason why I switched to Mixol. And that's the same reason I went to Moss. I ran out of Upstart, and he told me you really got to switch to Moss because you can cut into it twice as fast. So that was the key.
That's good.
So the swirl, basically you mix up the epoxy. In this case, what I have in here, and you can kind of see shades of it, is I have cobalt blue, which is a Epoxy mica powder cobalt blue. Then I have a little Pearl X micro pearl mica powder, which is a white, right? And then I put a few drops of Epoxy blue liquid in there. Mixed it all up. All right, then I pour it, making sure it's level. And then every 15 minutes, until it gets to the point where it starts to gel, I come in with a toothpick and I literally swirl it around. And you know you can't swirl anymore when you stick that toothpick and you touch it, and it doesn't start to seal back itself up. So you have to stay constantly vigilant on this. With the Upstart epoxy, I had to do it longer. With the Moss epoxy, I ended up doing it for about a half hour to an hour. The Upstart, I used to do it for up to about a couple hours, just because of the cure time. The other thing you do is you look for any bubbles, and you pop the bubbles, typically with I use a propane torch. I've used a heat gun before, but it doesn't seem to work as well. Other people swear by it, but Shane and I, we use propane torch. And unless we're doing something like the ocean epoxy ones, where you're blowing the epoxy around, okay, then you would use a gun. All right. So
that's the effect where you create like waves on the beach.
Yeah. So I'll pass this around, and you can see how fine-tuned these smaller letters are. So that's always interesting, is getting it to carve without chipping it out in between. But one of the good things about epoxy is it doesn't tend to chip out like wood, right? If you're using edge grain here or face grain and you're looking at wood and you're trying to do a wood inlay, one of the challenges you can get into is when you're carving it, is you start getting chunks of wood falling off. That's why typically a lot of people, when they do inlays like Brothers in Wood, Broin Wood, or whatever, typically use end grain because you don't get the problem with the chip out as much. But anyway, it's not as big a problem with epoxy. And the process, basically, you pour the epoxy, let it dry, take the next color, carve it out, pour that, let it dry, take the next color, and then it's how you think about layering those that matter. And then how you set up the vectors, and I don't have time to go into that, but so that you don't end up with gaps in between and so forth. Yes?
So one thing that you touched on a little bit that's really important is that I love the mica powder, and you can see the red and the Marine Corps logo. That's beautiful, but sometimes you just want a solid color.
Yes.
So if you want the solid color, don't use the mica powder, use just a plain dye, and then you'll get like the black over in the other one.
Right, that's what, yeah, exactly. So, and that's what I was talking about before with this. I should have just used a liquid dye or something, liquid pigment, to do the island.
The mica powder is so cool, though.
So here's another couple of examples. of coasters I did. So these are basically Martha Vineyard thing, of course. And what I want to show you is two different ones. And I was just playing with plywood to see the effect. And I actually didn't like it because what's going to happen with plywood? You're going to shave off the veneer, right? And when you're trying to levelize epoxy, what's going to happen? You have to sand it. So, but because I was joking around with it, trying to figure it out for my neighbor and to do some stuff, I started doing these plywood coasters because I didn't want to do hardwood coasters because I didn't know what I was going to do with them. And so this is an example, I'll pass this around first. This is an example of the first one, and it got, you can see where the layer got off and the burning and everything else. And I got, oh wow, I'm going to throw that one out, that sucks. And my daughter said, what are you talking about, Dad? That looks awesome. What? It sucks. Look at it, it's different colors. She said, it looks like an old map chart. And so when I showed my neighbor, he said, I like that old map chart look. Oh, I thought I screwed it up. So then, because of that, and I really wanted to see what it would look like, I went ahead and did what they call a flood coat, an overcoat on it. So here's an example, and I'll show you another example in a second, of a flood coat on epoxy. What that means is you've got your epoxy and your work all done, and then basically to cover up imperfections and not have to sand as much and stuff, you put a coat of clear, either bar top epoxy or art epoxy pour, and you just kind of put it over the top and wipe it around and let it harden, and it makes everything, makes all the mistakes disappear most of the time. But it looks cool. So there's an example of that that's really shiny.
Is there a similar process for all my woodworking that I just pour something over it?
Not unless you want it to look like epoxy. All right, and then here's another example of the next set of coasters. So I was trying to figure out, well, if I'm going to make coasters and I'm going to sell them, I need to figure out a way to mass produce it. Yes, sir.
When you're, well, finish your comment and then I'll ask my question.
And I want to mass produce them, I'm going to need a way that I'm not doing just one freaking coaster at a time and trying to figure out how to work my way through it. And then the sanding's a bear, right? So I need a way to deal with it so I can sand them more together. So what I did was, because I'm new to the laser and I'm falling more in love with it every day, is the different stuff. I used to laugh at Travis when he piped the laser because I said it's a toy I burn things on my CNC stuff with. But with the layering that you just saw from Chris and everything else, it's a tremendous tool. And the cool thing about it is it's so much faster than my CNC. I can play with it so much faster. But so now I've been spending a lot of time on my laser lately, so I'm not getting as much CNC time. I bought a big big laser. I wanted to point out here, so what I did with these is like he did with his layering, is I simply took and I cut out 4 of these at one time. So you see a set of 4. I cut them all out on 1/8 inch plywood, but I didn't cut the circle. All right, I just cut the inside diagram.
You mean the outer circle?
I didn't cut the outer circle. So I just cut what was inside here. And you can see by the way I set up the vector that it's all tied together. Okay? So this part and this part goes together. They don't separate. The first one you see I cut them separate, so it's harder to deal with. This one I just cut them so that they were stuck together. And I cut all 4 of these on one sheet. I was just doing a coaster 4 to try it and to see how I was really more interested in the sanding process than everything else. And then what I did was I took another sheet of 1/8 inch, so you can see this is layered together, and I just put that down, and then I put a clear coat of epoxy on that, and then while it was still dry and curing, I clamped the one that had the 4 designs on it on top of that. All right? I let that cure.
It was not cut out yet, right?
It wasn't cut out. It's just a square with 4 of these insides. I let that cure to attack. I didn't go all the way cure because I didn't want to have to try to get in there and sand and stuff to keep the epoxy sticking to each other. And then I went and I poured the blue. I went and poured the blue, which is mica powder, because I want that sparkle effect and that swirl. And then I, of course, had to swirl these for a while. And that dried. Now I had a sheet. And because I had the sheet, I could sand the whole sheet instead of coaster by coaster by coaster. So once I sanded the sheet, in my drum sander. All right. Then I took it to my laser, because now they're glued together. They ain't coming apart now. And I cut, because it's only a little less than a 1/4 inch, I cut the whole thing out. So it was, and before I did that, I had to put a grid around it so I could get back to the right location. That's a whole other discussion.
So, I'm sorry, the
So-
epiphany that you're giving us is that this is a multi-tool approach. You actually did the final cutout with the laser, and therefore didn't have to worry about the tabs or the separation or anything.
Correct.
You cut it out with the laser.
Exactly.
Got it.
So it was more, I was focused on the epoxy, so you can see that coming around. So this one had a bunch of layers, and I talked about that. So once again, yes.
Okay, sorry, you just raised a second question. Can we cut epoxy on the laser? Because no.
Okay, good question. The answer is no.
Okay. Second,
I went down that path.
so first question is when you're doing even just 2 colors, for example, on the We Shall Never Forget.
Yep.
I think you said you poured the black, then you went back and you milled the white, and you poured the white. How much flattening of the black did you do before
None.
you milled? None. Okay.
So when you're doing the multicolor pour process, it's only a few times where you change that rule. And this, by the way, this plaque is one of my playlists. I go from the beginning, and at the end of this, you send me an email, I send you this file in VCarve so you can make the plaque yourself and just follow the video through. All right?
I hope everybody appreciates significance. So what they're saying is basically you can get the zero clearances. You can get such a clean line between 2 different features by the way he's doing it, like pouring the black first and then carving into the black. You get like no separation between those 2 colors, especially something as complicated as the Marine Corps.
Right. So the key that I wanted to point out, though, because you asked the question, is I do not mill in between colors. So I put an X, say, out here on the wood, and I always zero off the same location. All right, so I'm always zeroing. I'm not zeroing off the top of where I'm pouring, or my design. I'm zeroing so that I always have the same reference feature. So that when I mill down to the surface of the wood, all my calculations for V-carving are from the surface of the wood. So that keeps my vectors the right size. The only time I do something different is if I've got some real minute detail that I have to get. I may do an initial surface of the wood down to the surface of the wood itself, but only slightly, and then I don't go down any deeper, and then I can carve from there a little bit deeper, or I might shine it a little. And then I get it down to a point where I'm not going to have to do much more sanding, and then I redo it from the surface of this, let's say, instead of the wood, because then I'm planning on only hand sanding from that point on, or sanding. I'm not going to do any big milling. It's just going to be finish sanding. And that's so that I don't completely erase real tiny details.
Along those lines, too,
It's a trick I don't cover in my video series yet.
Something you covered a little bit that's also really important is, and I've gotten burned by this, is surface your material first. Because if it ain't flat and you pour epoxy, guess what? You're gonna have that.
Yeah, you have
need to tell you the rest of that story.
You have to surface it on. You can use whatever you want. You can use a planer if you want and stuff. But I find the most reliable, because it's unique to your machine, and you always have to put it back into the same exact spot every time on the CNC, right? So, so the most reliable is to always surface it up with a surfacing bit on your CNC. That's the most reliable, because you'll always have it relative to how your gantry's cutting. Even if you're out a little bit, you're always going to be out the same spots. Right?
I got a kick a minute ago. Rob said it in passing, and I can't tell you how incredibly important it is. He said, I put it on a level surface and then pour. Those words, a level surface, or you want to make sure your piece is level, are critical, because otherwise it's spill.
As he said,
it's a huge issue.
Epoxy will go everywhere.
Yeah.
It'll go
Even
where?
when you do it good, it will go everywhere. And it's sticky. So I do it up in my office in the house, because I want it temperature controlled. So I set up a little corner. You'll see that on my videos where I'm doing it. He's doing it there. Oh, yeah. But I also have the floor lined with black plastic bags and stuff. All right.
Did you do a heating tray too?
You watch those pros on
I have,
videos, and they're still spilling it all over.
oh yeah, everybody does.
Everybody does.
I keep it at a temperature control in there, yeah.
Yeah.
Just with normal heat, because I keep my house between 70 and 75, so. And then I put an air purifier in there recently because I ended up with some problems with the deep pour stuff. So,
I mean, that's in 90 minutes, so if you're not wrapping it up faster, just be aware of
yeah,
that.
I need to, anybody that wants to leave, feel free. This is that same, this is how I used that epoxy pour is what I was showing you. So basically I did this as my first, this was one of my first epoxy journeys, second or third. And so I actually did this on a separate piece of wood. And then I turned around and in fact, lesson learned, I did this on end grain. You know what happens when you do epoxy on end grain? It sticks to the whatever you put it.
Goes right through, yeah.
So I actually had it on some paper, and when I went to pick it up, the first pour, the whole paper and everything, what the heck's going on? And I kind of knew this, but I didn't believe it. So I had to rip the paper off and scrub it off. Of course, with some sanding, I could do that. And then I instantly covered all the back with packing tape, right, Teflon tape. And then it was okay from that point on. Plus, it was halfway sealed already because I had the epoxy on it. But so don't do end grain, or if you do, recognize it's going to go all the way through the wood. So I did this on a separate piece of wood just to play with it and see what I could do with it. And then this is why I said to Howard, well, you can take the plug and put it somewhere. Guess who did that? So I had made this flag. And I'd sold it, and I told the person, hey, after I made it and I was getting ready to ship it, I noticed there's a little crack in the flag. Do you want me to send it to you at a discount, or do you want me to make you a flag that doesn't have any flaws? He said, I paid you for a flag with no flaws. So I said, okay. So I sent him another flag with no flaws. These are all wood inlays, by the way, what Howard was talking about.
Had you done the epoxy yet on that?
No. Okay. So I did all of this, and there was no hole there for that. And then my neighbor said, well, I'll take the flag. And I said, okay. And I gave it to her. And then she's a Marine. And I said, well, do you like this? Because I was playing with this. And she said, oh, yeah, amazing. I like it. And so I said, okay. So I said, well, how do I get it in there? So then I just basically did a pocket path, right? And just simply glued it inside the flag. So.
Oh, it was a separate pour that you did, and then you...
I did this all separate.
Got it.
It was sitting off to the side as just as like an envelope.
Got it.
All right, and so here's another example. So this is another example of a flag, and in this case I thought, well, what if I do everything mostly epoxy? So you can see that all these stripes, the field, everything is epoxy on this one except for the white wood.
Can we still call it woodworking?
Well, it's about half and half, right?
Okay.
Well, it's maybe 3/4 and 1/4. So. And so I was just trying to show you the details. So these are two different colors of gold, and the blue, and let's see, and then the blue there, blue here, the black, and then the white up there. All right. Now somebody mentioned that I didn't. Gosh darn it, I didn't have it in there. What I wanted to show was a picture originally I had, because somebody mentioned about Boehm. What happened? The way epoxy pours is cures, it's exothermic, heat. What happens when you put heat inside a wood? Right? It tends to cut. So when I originally looked at this, when I originally did this flag, it was supposed to be a flag that I was doing for a friend that was like this. It was out of maple, and you see there's a lot more epoxy in here, right? And so by the time I got done, the flag looked like this. It was bent. I said, did I just spend all those days on a wasted project? Man, I can't figure it. And then when I was trying to mill it on the CNC, it's not flat anymore. So I ended up on the CNC screwing it to the bed so it forced it flat, right? So now it's flat. Well, that's real good for getting it off and milled, but what are you going to do long term? You think anybody wants a bent flag on their wall? No, and this was a gift, but I still didn't want to give it to her bent. And so I thought, well, heck, when I did it and put it down my bed with screws, it was fine. It wasn't enough where I couldn't hold it, so I made a shadow box. And I put it in
flat.
And I put it in fact, and I forced it flat, and it's still that way 2 years later.
It just stands out from the wall a little bit more with each passing month.
Yeah. So anyway, so that was an interesting thing. In other words, there's ways around it if something happens. This was my very first epoxy pour.
I think that's the pour that made you famous.
Yeah, that was my first one. And can you see what the problem was there? Anybody pick that up real quick?
Yeah, it's a Denver Broncos.
No, that's definitely but as you can see, you can kind of see the blue under this white, right?
Yep.
So there's an example of I'm not using enough powder and liquid pigment to make it so it's truly opaque. And that's one of the biggest problems people that do my channel and feedback is, Rob, I keep getting these color bleed throughs. That's because you're not getting enough epoxy in there. And here's what you got to do to try to do that. So basically, I won't get into all those discussions because we're running out of time. But there's tricks you got to try to do. This was another one with an Encinitas Fire Department that I did, and this is that board I just passed around. And here's a couple I did for the San Diego woodworkers here. This is what got me into Aspire, was this shape of board, and we won't go into that story, will we, Travis?
No, we don't need to.
Okay, but Travis can tell you the exact size of a Ritz cracker and how it will fit inside that trough.
He wanted to know what shape to use, so I went out with calipers and measured some rice crackers, and that's how it's designed.
And that's a true story.
It is.
So then I got frustrated with having to always turn these handles because I'm not a real good turner and getting them on there, although I like the look better, so I tend to go back to that when I make them these days. And so that was originally a walnut inlay. And what happened was I had this one that I'd done from the first year I gave them to the SDFWA with walnut, and it was a pilot board at the time. And Gary comes to me the next year and says, you said you'd make some more of these boards, I still have this pilot one, can you do this? And if you just heard Howard say about his wood inlays, what do you need to use? The same bit, the same vectors and all that. I did that a year ago, how the heck am I going to put a walnut inlay in there? Well, I was into epoxy by this time. And I'm scratching my head and getting ready to throw the board out and tell Gary I can't use it. I said, wait a second, epoxy doesn't care what's the bit I used. It's liquid, it'll go anywhere. So that board came along and it was real easy to finish because I didn't have to worry about the exactness. That's the advantage of the, I'm telling you, that's the advantage of the epoxy inlay, using that for your inlay work, over doing the wood inlay, is epoxy is actually much more forgiving, because it's liquid and it'll flow into the cracks in the areas. All right?
So if you have, go back to the Marine, or one of the Marine Corps logo, well, if you can get to it easily, where you have there, so you have wood and you have epoxy. And I want to finish that, and I want to be able to sand both. The problem is to get the epoxy of the shine that I need to go like 3,000, 4,000, really shine. But if I do that to the wood, it's not going to take a finish.
Well, in this case, I actually went to like 1,000 or 1,200.
But how do
it's only recently that I started going higher.
Sure. How do I deal with the differential?
It's cool. It works fine.
No. Let me finish. So wood wants to go up to like 220. Maybe if I want to put a finish on it and have it adhere.
No,
epoxy
it goes all the way up. I'm telling you, I
take your
do
wood
it
up to
both.
3,000.
Yeah.
Okay.
And there are products that will work for that. For example, Odie's Oil advertises that it'll work all the way up to whatever shine you make. That's one if you want to oil it.
Okay.
But typically, if I have something like this, it's not going to be food safe. I'm not worried about food safety. I use lacquer. I use depth spray on lacquer.
Okay.
And it will adhere to both.
Even at a high polish.
Oh, yeah.
Okay.
At least it's never failed for me, let's put it that way. Now, I haven't typically gone up to 3,000 or 4,000 until I get to some of this more recent work I've done.
Do a clear pour of the epoxy on top of the whole thing.
Couldn't you just put your tabletop epoxy on it?
Well,
Yes,
that's the problem.
I'm going to get to that. I'm going to get to
It won't
that.
stick to the wood if the wood is 3,000.
Let me get to that. All
If you
right.
polish the wood to that
I'm
level,
getting there.
Epoxy won't stick to it.
Yeah, okay.
By the way, this is another one, and I wanted to show what you can do with your mica powder coloring. So, in this one, I didn't do my wood inlay quite right. It started bubbling up. I said, oh, I ruined it, all right? And so I pulled out the wood inlay, basically, remilled it, just slightly bigger, and then I used resin to pour it in. And look at how this looks like Claro walnut. It's a mahogany, black diamond mahogany color. It's beautiful, and it does a beautiful job on walnut. So you can actually get woodish colors, is my point, in your epoxy. This was another one that I did early on for my sister-in-law, where one of the people will say, well, I can't do epoxy because I need to get in there with the CNC. Well, make your build process in layers or around it. So I did the flat bottom of this with my epoxy work and got it all to the point that I needed to. And this was an example of one where I actually used Odie's oil or something like that, but I only sanded it up to like 1,000. All right, but it still worked fine. And then I built the box and slid in the box and everything else, typical joinery type stuff. So think different. Here's an example of one I did recently for a client who wanted a trophy base, whose thing was that. And this is the other one I do the video playlist on, including the mistakes I made. Who can see the mistake in this one real quick? Clue, look at the green. See how it disappears over here? So there was a very, very thin line, right? Very thin line. Remember when we talked about warping and all that other stuff?
So you milled off the epoxy at the
So apparently, without even realizing it, it had warped enough, not much, because you're only talking about 0.01 inch deep. Not even 0.1, you're just talking about really narrow pores. So what happened is, actually when I got done milling, you could see it. It was fine. It was the sanding process that got me, all right? So the sanding and finishing process got me there. So another example of that kind of issue. You can also see that, I'm pretty sure on the white I didn't use mica powder. So here's another example of where I started going, and that is more the river type. That's a whole different ballgame, folks. But the cool stuff about the river epoxy, or I'll call deep pour epoxy, is that you can take the crappiest looking wood, and actually it's not crappy, it's beautiful wood, but I should say checked up, cracks and everything else, and turn it into something really gorgeous. Look at all the cracks in this wood. You can see all of that? By the time I got done, it's nice and smooth, and you never know it because they're filled with epoxy. These next few were gifts to the SDFWA. I actually used SDFWA's wood, and these will be in that holiday sale. All right? And this one doesn't show in its finished state because I put handles and stuff on it. Here's another one that I just recently did. When I got this wood, it was all spalted and rough and falling apart. Now, what the heck? I can't hurt anything. So I poured the green in there and got it mixed up and all that kind of stuff. And then I started sanding it, and it just, I never could get a nice smooth finish, you know, even though I went up to 1,500, because in the wood, some of it's still a little softer than other parts of the wood, even though it had been covered with epoxy, right? And I'm thinking, oh, well, I'll throw out this project. No, I can't throw out this project. It's cool. The only thing that's bad about it is the fact that when you touch it, and people will touch it, it feels a little rough in some spots. And no matter how much I sanded it, I couldn't get it away. Hence comes the epoxy coat that he asked about.
Bar top.
So yeah, so bar top and a flood coat on there, and look at the difference. Now that's smooth as a baby's bottom. All right, when you run your hand on it, I've got an example here. So this was my next one, and I'll pass this around. And people talking about lasering, so don't get fooled. The laser that you see on this is only in the wood. And that's
prior
the
to the
advantage.
epoxy, right?
Prior to the bar top epoxy. So I actually poured everything, and then I lasered these 5 lighthouses. I call this my lighthouse edition. These are the 5 lighthouses off Martha Vineyard. And so I lasered the lighthouses into the wood that looks like kind of driftwood. And I thought, well, that looks pretty cool, but a lot of people won't like the fact that when you touch it, it's got grooves. If you look at the back, my logo's on there. I haven't put epoxy on that. I'm not going to because they're not putting stuff on it. A lot of people won't like that. Some people would, but most people wouldn't. So how do I take care of that? So then I just poured the flood coat, and this is an example of a flood coat, over the top of the laser engraving, and it actually gave it kind of a cool effect. So This is an example of a river pour with a flood coat.
The river pour is deep pour?
Yeah, river pour is my term for deep pour, which means
1 to 1?
Mine was 1 to 2 actually. I'm using ultra clear deep pour, but there's a number of brands. Some are 1 to 1, some are 1 to 2. Just depends on what brand you use, and it's got to be able to go the depth, right? Otherwise, you have to do it in layers. So tabletop epoxy, which is what I always use for the multicolor stuff, has technically a limit of 1/8 of an inch, but you can go down to 1/4 of an inch with it without a problem.
So the tabletop, the surface is 1 to 1?
Well, 1 to 1 is a formulation.
Yeah, I know.
But
Yeah,
the
no.
viscosity is whether it's tabletop or deep.
Right.
That surface over there was 1 to 2.
Okay.
It was, but it's because the epoxy I used was 1 to 2.
Yeah.
It's ultra clear epoxy. If you go to Moss epoxy or some other art resin epoxy, it'll be 1 to 1. It just depends on what you use. It's what I used because it was on sale, and I wanted to try it out. So here's my latest board I'm in progress on, and here's an example of where I tried to use the CNC, laser, and epoxy skills all together. Again, this is a deep pour epoxy. This is, guess what? Martha Minion. So this is one where there was all kinds of checks in the wood. As you can see, this is what I meant about you can take wood that doesn't look so hot when you first look at it, and you can turn it into something pretty cool. And you can see I haven't shined this yet or anything. So this is what the epoxy looks like. I was going to pass this around. When you do that first surfacing with the surface bit on your CNC to get it level, this is what it's going to look like, right? And that process, you saw that coaster came around with all those lakes? Oh, guess what used to be on here? Lakes. Not anymore. That's because the wood was in such bad shape by the time I got it milled, and because the original depth I made of those lakes, I ended up shaving those lakes off. Well, actually, there was like the tiniest bit, and I didn't want to have to try to put it back on and match it, so I just basically shaved it the rest of the way off. And then I burned with my laser in the wooden parts the text. And then because when I first poured the epoxy on, there were areas that didn't get all the way into the cracks and get them nice and solid the way I wanted to. I went ahead and mixed up some the epoxy after I poured the clear and got that done. Then I went ahead and put a little tint in there. And I wasn't worried about the tint actually matching this that close because they're just little cracks. They're going to be little things. You won't see it, right? So I'm at the point now where this is cured for a couple days. And when I quit playing with my laser, I'm going to come back over and I'll just sand this, right? And then what I'll do is I'll go through the process of sanding this and now I'm using a polisher because it's doing a cool job. So now I actually use a 3M perfected polishing system on the resin part, and it gets almost like that. You poured the tabletop on it, it gets that.
If you can wind up sometimes.
Yeah, this is about done actually. So you can take a look at that, and then the next slide is basically
Perfect.
any questions or follow-up. Please don't walk off with my coasters. I got to sell those or my serving board.